0. Good evening. Now on to the second portion of what Kristen asked for. In this case, we're going to look at taking the region we just found the area of, and we're going to revolve it around the x-axis. So the first thing I want to do is I want to pull up Maple and take a look at that. And notice I've already set it up. The true area is 32 thirds pi cubic units. Let's do some disk and let's animate that so you can see the disk going through. There we go. Now can you see these aren't disk, they're washers. So we have an inner and we have an outer radius. Now I'm going to go ahead and close that. I'm going to turn that baby so you can see it. Oh, let's see. Yeah, I'm challenged technologically. Now let me animate it. Bam, bam, bam. Can you see we have a disk, a circle minus a circle. How cool is that? All right, now let's go one step further. Here we are. All right, let's go through the process. First, I reflect the area. This is, I can call it region R. If I'm not, I'm calling it region R now. So this points down 1, 2, 3, 4 right there. Just do the best you can. I understand it's going to cause some issues. Now, can you see the donut holes? And no, I am not going to give you donuts like Joshua has asked, but I pull out the cross section. Now, here we go. This is an X and this is a Y. Now this is where you need to be careful. This outer one, if my memory is correct, is 4x minus x squared. The inner one is x squared. So the area of a cross section is pi, outer radius 4x minus x squared squared minus x squared squared. Okay, well let's do some algebra there. I think it makes more sense here to do algebra and to clean this up. Yeah, I know, this is really not nice. Okay, 4x times itself is 16x squared. 4x times 4x is 16, doubled is minus 32, but don't forget the x cubed, plus 16x to the fourth minus x to the fourth. Cleaning this up, we get a pi. We get, well, that's the only thing I can simplify, and I think that's 15. Don't forget x to the fourth, like Mr. Isaac did. Okay, now, so my volume is the area of a cross-sectional area. It goes from 0 to 2. Pi is always in everything, so it's 16x squared minus 32x cubed plus 15x to the fourth in x. Okay, here we go. We're going to gain a power. Pi 16 thirds x cubed minus, this becomes a 4. 4 goes into 32 8 times, 8x to the fourth, plus this becomes a 5. 5 goes into 15. I want to say 3. Don't check Mr. Isaac's math. That could be wrong. From 0 to 2. Okay. Now, I think we can all agree, since there's an x in every one of these terms, that when I put a 0 in there, the back term, I'm going to get a 0. It's the front term that really is going to determine everything. So here we go. This is going to be pi 16 thirds, 2 cubed I believe is still 8. Please check my math. 2 to the fourth I think is 16, plus 3 times 32, minus, and that's a collective 0. Okay, this is where it's going to get ugly. Okay, here we go. Let's see. 48 carry the 4 is 128 thirds. 24, or no, 8 times 6 is 48. We're going to carry 128 plus 96. Okay. think about this. 128 is farther away from 0 than 96, so that's minus 32. Okay. Uh, if my memory is correct, 32 over 1 is the same as 96 over 1. And don't forget the 8, like Mr. Isaac almost just did. Wait, hold on. I made a mistake. Give me a second. I changed the 3 to an 8. Yeah, that does happen. 128 less 96 is 2. So this is 32 thirds pi cubic units. Now, let's take a look at what the technology told us it was going to be. And tools. We want tutors. Oh, come on. Volume. Excuse me. I'm going to put x squared here. Four times x minus x squared here from 0 to 2. Let me display that. Oh, come on. Let's see if this works now. Unable to compute. So why is this not working? Oh, let's try this. No. I think I had cap locks on. That sometimes. See, CAS can be 32 thirds pi cubic units. That's what we came up with. Now I will finish this in the morning.